Good morning. Are we over there? I can't see Kingsport this morning. There we go. Thank you, David.
I'm it.
Now I see you back there. Are you the only one there?
Yes.
So far? Wow.
Yeah, so far, yes.
So far, so good, huh? Well, I was running behind myself this morning, so maybe that's the deal. I don't know what it is. But just when I think I'm going to be here at a good time, it doesn't happen. So, all right, thank you for getting it to where we can see there. All right, so let me find our page here where we were working last. We were finishing up section 6.5 last time. Started into a little bit of 6.6 on phase shift. They turn the heat on in this room? Does it feel like heat in here to you, or is that just where I just walked? It feels warm. Well, we'll give it a minute and see. You all know we're having a test on Tuesday. Everybody's aware of that. Yes, go ahead. What assignment was that? Okay, that's just still practice problems like I give after every class. So, yeah, I'll pull those up there for those of you who did not see that. Let me get the screen going here. So. All right, so here on your D2L site, let's go over here to your section 501. I put a little announcement here. I don't know, does that show up when you get an announcement like that? Does something happen, bells go off or something or another? No, nothing like that. You get that little red dot in the alert area. That's what you get, isn't it? Up there maybe. Update alerts, okay. And so I was telling you here, which we'd already said in class, the test will be on Tuesday. It'll be over Chapter 6, what we've done in Chapter 6. And I put up some review problems from the textbook for you to use just kind of to practice with, okay? So that's all it is for. You do not have to turn those in. That's just some things in the chapter review at the end of Chapter 6 that I thought might be helpful for you to go back and look at for some new problems. You can always still use your homework problems that we've, homework problems, the ones I've given you to practice on every time, right? So those would be good as well. But these are some extra problems here to help you out. So that's over on page 430, 1 through 51 odd, 57, 59, 63 to 67. I'm sorry, 77 odd. Can't read this one. So I'm passing around the attendance sheet over here, and because I normally don't get here in time to put it back there like I should, so you could sign in as you come in. That would be a little better. Somebody put my name, they thought, on the sheet last class, and so let me reintroduce myself. Okay, I'm Jamie McGill, Yes, Ms. Robe was supposed to teach this class originally, but I'm not Ms. Robe. I'm Ms. McGill, okay? So anyway, just to clarify who I am so that you do know who you're talking to here, okay? All right, so that's okay, but I just wanted to clarify since somebody did not know. I don't know who, but maybe several of you, because that was the name on the schedule for a long time. This class got switched over right before classes started, I guess. Right? Okay, but that's all right. I just like you to know who I am. Okay. All right, then let's go to the homework. There's somebody in Kingsport. I'm glad that we're there. So, not putting you on the spot or anything. Let me go back and say though, just so you know, on this news page on D2L, is that Cheyenne over there? Is that who that is?
Yes, it is.
Okay, thank you. Just on this news page, you may have already seen it, but we have some review problems here from the textbook just to review with towards Tuesday's test, okay? So they're listed here on this news page. Okay, let's see where we are here. Last class I have down that we finished up talking about graphs of secant, cosecant, tangent, and cotangent, and you were looking at some problems to do with those, first off. And then I think we barely started talking about phase shift because then we had the unit circle quiz. And after I finish talking, we'll get back to the unit circle quiz and talk about that also, okay? All right. So on first off, on page 413, let's go over there for just a moment. Well, 413, 414 in there. Maybe you were more on 414 for today, 15 to 25 odd. We were looking at some problems there having to do with the graphs of tangent, cotangent, secant, and cosecant. Some key things you want to remember here. To graph y equals secant x. First graph, what?
First you graph the sine.
Which one? I think I heard it over. Here's some cosine. Graph the cosine. Graph the reciprocal function, okay? You're on the right track there. Make sure it's the reciprocal function there. So first graph that one. And so like we were saying last class, you know, we know cosine's 2 pi periodic. Goes up to 1, down to -1. We know what cosine looks like. So in your mind or on the graph, graph cosine, right? And then we draw these little shapes off of cosine. We have asymptotes in between. Okay. See how that cosine graph would have gone in the curves, would have gone under the curves I've drawn here? See that? Okay, the asymptotes are showing us where the graph or the function is undefined. That's what it's telling us, where the denominator is equal to 0. Okay. Likewise, if you're graphing the cosecant of x, that's where you would graph the sine and do the same procedure. Y equals tangent x. Would one of you care to pull that door up back there? It's a little louder than usual today. Thank you. I don't want us to get distracted. Thank you. All right, so the tangent graph, we said it looks kind of like y equals x cubed, but repeated over and over. It also has asymptotes. The asymptotes for tangent x, for the y equals tangent x graph, will be at the same place as the ones for the secant graph. Okay, because both of them have cosine in their denominator. Does that make sense? Tangent sine over cosine, secant's 1 over cosine, or the reciprocal of cosine. So they have those asymptotes at the same place. So both of these are undefined. What types of values? Yeah, odd multiples of pi halves.
So both are undefined at that?
Yes. Because it's because secant's 1 over the cosine of x, and tangent is sine x over cosine x. So the part that's making them undefined is their denominator. When the denominator is equal to 0, the fraction will be undefined. So in both of these denominators, we have cosine x. So when the cosine is equal to 0, that's when these reciprocal type functions or quotients that have cosine in the denominator will be undefined. And then we can think back to the unit circle, to think about where the cosine is equal to 0 if we're not sure. Where's the cosine equal to 0? Well, up there at the top where we have a point, 0, 1. Down here, 0, -1. That's at those values, pi halves, 3 halves pi. And then if we kept going circling around, we would see it's those odd multiples of pi halves. You'll see what I'm saying there? I'm using the unit circle to kind of help me get where the cosine is equal to 0, if I'm not sure. I could think about the cosine graph, where we graphed it, Where is it 0? It's 0 when it's hitting on the x-axis. At those values, where it's crossing through the x-axis. The x-intercepts are where the cosine function is equal to 0. All right, so then the cotangent, how did it change from the tangent?
It's descending instead of ascending.
It's okay, so it's decreasing. Instead of like the tangent graph we see, it's ascending or increasing. And the cotangent will be decreasing. So let's put that up here.
Also, the asymptotes are on the integers of pi.
Right. Also, the asymptotes are at pi, 2 pi, at the integral multiples of pi. Negative pi. Also, we have one here down on the y-axis. And the graph itself was decreasing. It comes down like this. Well, it doesn't curve up there. I just can't draw this morning. So it's crossing through at those values like pi halves, 3 halves pi. That's where it's hitting that x-axis there. So this one is undefined at integral multiples of pi. 0 pi, which is 0, 1 pi, 2 pi, 3 pi, all those values. Okay. Cotangent, again, let's recall the cotangent is the cosine of x over the sine of x. So wherever the sine is equal to 0 is where the cotangent will be undefined. All right. All right, so we had some questions here about these types of graphs. We had a few to graph, to just sketch the graphs and have an idea of what they would look like. We mentioned in class last time that if we have a number out in front of, like, cotangent, tangent, instead of thinking about it being amplitude, we know it's going to stretch that graph up. The multiplier is going to change the looks of it, of the width of the shape. So if it's a 2, 3, 4, whatever, it's going to stretch this thing here up more. If it's a fractional value, that means it's going to increase slower, so it would widen it out a little bit more, okay, make it slower to get from top to bottom down here, okay. Does anybody have a question on 414 that you want to look at? Okay, number 11 on 414. Okay, so part of number 11 is how it's written. So if you're looking at that one, here's what it says. For what numbers x, and then it says negative 2 pi is less than or equal to x is less than or equal to 2 pi. For what number's x, and then it has this. Is this the one you're looking at? Okay, well, let me finish this one, then we'll come to the one you're on. Okay, you must be on the next section, I bet. Maybe? I don't know. Okay. Okay, I thought we still had some on this page also, but let's do this one anyway, and then we'll come to that one, okay? For what number's x, negative 2 pi is less than or equal to x is less than or equal to 2 pi, does secant x equal 1? So basically, this is what we want to know. The reason I'm looking at that one is because of the wording. The reason, even though that's not the one he intended, the wording's a little bit strange, maybe. So for what number's x, and this is saying where x is from negative 2 pi to positive 2 pi. Those are the values we're looking for. Where does the secant equal 1? We would want to think about the secant being the reciprocal of the cosine. So the secant will equal 1 if the cosine equals 1, won't it? Secant and cosecant, secant and cosine, I'm misspeaking here. Secant and cosine are reciprocals of each other. So if the cosine's 1, the secant's 1. That's how that's going to happen. So where is the cosine equal to 1 on that unit circle?
Is that pi quarters, or yeah, pi fourths?
Now hold on a minute. The tangent's equal to 1 at pi fourths.
Oh, okay.
Right?
Yeah.
We've got the sine over the cosine, or the y over the x. We just want to know on this one where the cosine's equal to 1. Where's that going to happen? Anybody? At 2 pi, and where else? Is the cosine equal to 1 at pi?
Negative 1 at pi.
Negative 1 at pi, so be careful. So at 2 pi, we know it's equal to 1 at 2 pi. Where else? Remember, we're looking for any values from negative 2 pi to positive 2 pi.
It's also going to be at negative pi and at 0.
Not at negative pi. 0 I'll take. Okay. Here would be negative pi, right? Or 0. All right. At negative pi, though, I have the coordinates negative 1, 0. Here I've got 1, 0. Actually, the only place that cosine is going to be 1 is over here at this point, isn't it? So whatever angles fall at that point. So we see we've got the 0 angle. We go all the way around. We're at 2 pi. So what other angle might we have in there? Negative 2 pi, right, because going to negative 2 pi just takes us back that way to get there. Just at those values. So maybe it is a good thing we looked at this because the wording is strange, right? It sounds a little weird the way they're asking that. But it's looking for all possible values from negative 2 pi to positive 2 pi where the cosine is equal to 1. Then it says, same situation, but where does the secant equal negative 1? It actually asked about the secant, but we turned it over to cosine because of them being reciprocals. And if your secant's 1, then your cosine would also be 1. And cosine's a little easier for us to think about normally. Do you agree? Sine and cosine and tangent are a little easier to think about in our heads than the other three functions. Where does the secant x equal negative 1? What's the cosine going to be if the secant's negative 1?
Be pi.
Okay, so at pi. But what does the cosine equal if the secant's negative 1?
Oh, negative 1.
Negative 1, okay. So that happens at pi. Where else?
Negative pi.
Pi what?
Negative pi.
Negative pi. Anywhere else? No, I don't think so. We can't get a 0 in on that one, can we? That's not going to work. So the phrasing of the questions are a little strange sometimes, so the way they're asking, but we've got to be able to interpret those questions. For what values from negative 2 pi to positive 2 pi does this value happen? That's what it's asking you. Any questions on how that's asked there? Now let's do the real number 11 that you wanted. So what's the real number 11? Over on page 424? Okay. All right. Remind me first, how far did we get with the phase shift last class? Not very. That's what I thought. We talked about phi over omega, and we talked about setting the argument equal to 0 would be an alternate method to find that, right? We didn't go quite that far.
The last thing we talked about
I
was
just
phi
wrote
over
it up.
omega.
Yeah. Before we do this problem, though, let me do something else. Okay, I will do this problem, but hold up on this problem just a minute. Okay. Let's go back just a moment, because I felt like we needed to do a little bit more with this stuff. A cosine omega x minus b, or we might have A sine omega x minus phi. Okay. When we were looking at these forms of equations, we said that the amplitude is equal to the absolute value of A, the number out in front there, the absolute value. The period, or how far out the trig function goes before it starts repeating, that's kind of what we're referring to as the period there, is 2 pi over omega. What was the only trig functions that, there were 2 trig functions that did not have a period of 2 pi over omega. Do you remember which ones those were?
Tangent and cotangent.
Tangent and cotangent, and their period was?
Pi.
Yeah, so pi, so therefore if we're working with them in an equation, it's pi over omega. Phase shift. I think all we'd mentioned on Tuesday was that phase shift is a horizontal shift, and we think of it, the graph will shift in the opposite direction of what we would think of when we look at where that shift is added or subtracted onto it. Okay, it's usually within, well, it would be here within the parentheses. Phase shift is phi over omega. Once you get that phase shift value, it tells you exactly, if the phase shift value itself is positive, that means you're moving to the right. If it's negative, you're moving to the left. That's what it's telling you. When we're looking at this, though, we also said an alternate way, or I don't know if we said it, maybe we did. I thought we did. An alternate way to find phase shift. A lot of people like this way because it keeps their signs, positives and negatives, a little bit more clear. That would be to set the argument equal to 0 and solve for x, with whatever you get for x being your phase shift in that case. What am I talking about, the argument?
Omega.
Not just omega. Omega is the coefficient of x. What's the argument of the trig function, though? Let's look at this right here. What's the argument of my trig function up there in the box? What am I taking the sign off? Omega x minus phi, right? All of that. The argument of the trig function is whatever you're taking the trig function off. Okay, always. So if I take omega x minus phi and set it equal to 0 and solve for x, all right, some of you don't like this where I don't put the numbers in up here, but what would I do here to solve for x? Equation solving steps. What would I do? Not yet. What would I do? To get x by itself. That's my goal right now.
I would add phi to both sides.
I would add phi to both sides too. That's what I would do. All right, so we would have omega x equals phi. Now I'm still trying to get x by itself. So now what would I do? Now I want to divide it, right. I just wasn't ready to yet. Okay, so I get x equals phi over omega, meaning that is my phase shift. That's what I've already told you was the phase shift was phi over omega. This is an alternate way to find it, though. When you've got real numbers involved, you may want to use this way. Sometimes it's hard for people to look at the argument up there, omega x minus phi, and get the sign correct on the phi over omega part. That's where the trouble comes in. You can try it both ways when you're practicing and see. All right, so let me put one up here, and let's see if we can find these things at least. So this is number 5 off of page 424. and it's y equals 2 cosine 3x plus pi halves. Okay, 2 cosine 3x plus pi halves. We want to know, right now in the space, I've got a little bit of space here, we're going to put the amplitude, the period, and the phase shift. So the amplitude, everybody's going to get this right on the test. What is it? 2. Right there it is. Right. The absolute value of that is where we get the amplitude. Period will be 2 pi over 3, because there was my omega value. So I've got a cosine omega x minus phi was the form I'm looking for. Right, omega x minus phi. The phase shift is phi over omega. Let me give you a minute. What will you put for that?
I got negative 3 pi over 2.
Okay, I've heard 3 pi over 2, negative 3 pi over 2. Anything else? If I go with phi over omega, what will I get? All right, so now, instead of doing it that way, I want everybody for just a moment to jot down 3x plus pi halves equals 0. Remember my alternate method over here. I want you to put down there 3x plus pi halves equals 0 and get x by itself using the steps we used with the symbols over here. And then I want you to tell me what you think the phase shift is. If you still are the same or if it's something different. So what do you think? Pi over 6, I'm hearing now. Anything else? All right, let's go through it and see. Phase shift, if I take the argument, set it equal to 0 and solve, I would be subtracting pi halves. I get 3x equals negative pi halves. Now I'm dividing by 3. X equals negative pi halves divided by 3, which means times what?
The reciprocal.
Yeah, times the reciprocal 1/3. So I'm getting negative pi 6 for my phase shift. Okay, so when you all first did that and we're getting that 3 pi over 2, I see where you got that, but be careful on these where you've got the fractions involved. We had the pi halves divided by 3 in some way. It is negative though. Negative pi 6 means we're going to move left pi 6 units. So here's what I want you to think about a minute. Up in that argument we had a plus. Remember, horizontal shifts are opposite what you would think. If it says plus in the parentheses, okay, that will typically indicate to you that you're going to move left. What happens with the form? Focus up here on the form just a moment. We said the form had to be omega x minus phi. What we really had then up there was 2 cosine 3x minus negative pi halves is what we really have if we want to look at it as omega x minus phi. Do you see that? I would have to write it that way to think of it back in that form. Because it said plus, I have to think of it as minus a negative, making my phase shift be the phi value itself over the omega value. Okay, so that would still get negative pi 6. That's why, though, a lot of people prefer to set the argument equal to 0, and it usually keeps your signs a little straighter. It will come out correctly if you do the algebra instead of, sometimes people don't like to think of the phi over omega because you've got to think about, oh, is there a plus there, is there a minus there, what am I doing here? It's easier to get the signs mixed up. Anybody have a question so far? We're going to look at another one. Okay. All right, let's look at another one. We didn't graph this one mainly because I ran out of space, but we'll graph the next one. All right, so let's look at, we are going to get to that other one down there, but let's look at number 8. Y equals -2 cosine 2x minus pi halves. We want the amplitude, the period, and the phase shift. Okay. I'll get a graph set up, so we'll graph it here in a minute. All right, so what's my amplitude here? 2, the absolute value of the -2. Now, I will want to remember when I sketch my graph that because it's -2 out front, what do I need to do for that? Start down at -2, so to speak. Yeah, we're flipping it over that x-axis, so we're having it go through down at -2. All right, period is 2 pi over, what's omega? 2, so that just turns out to be pi. The period is pi. Okay, so this was my A there, cosine omega x minus phi. You might want to write that stuff down as you practice, just to make sure you're getting that in your head, you know, what goes where. All right, and then the phase shift. Everybody take just a moment. Don't answer just yet. Let me give everybody just a minute and see if you get the phase shift, okay? Give everyone a chance, either by looking at it, setting the argument equal to 0 and solving it. Some of you look like you have it. You have it? What did you get? Pi? Pi over 4? Anything else? All right. Anybody else get pi or pi over 4?
I got pi over 4.
Okay, something. All right, let's look at it. The phi value is the pi halves. As long as it's in that form, omega x minus phi, we just take that numerical part, the pi halves. You know, now if it said 2x plus pi halves, we would have had to have written negative pi halves. Does that make sense? There. And it's over omega, which was 2. Okay, so this is pi halves divided by 2, which means times 1/2. So it is actually pi fourths on this one. We're moving pi fourths units which way?
To the right.
Yeah, I heard both. There's a 50-50 chance. Right? So it's to the right. How do we know that? It was positive. The phase shift was positive. Okay, the phase shift was positive, and up in the parentheses, though, we see that, you know, 2x minus pi halves. That's the part where we've got to think a little opposite up there. But once we get that phase shift number, if it's positive, then we're going right. If it's negative, we're going left. So that's the one probably better to rely on, is what you get down here. All right, let's see if we can sketch the graph. I see the amplitude's 2, so I've got it going up to 2 on the y-axis and down to -2. I see it's a cosine graph. We've already talked about we've got to, you know, reflect it over the x-axis. Period's pi here. Period's pi. So let me have it go out to pi right there. Halfway there's pi halves. So that's pi halves pi. This next one would be 3/2 pi if I want to label there. So first let me graph it without the phase shift. Okay, I'll do a dashed curve just to put it in without the phase shift here. Without the phase shift, we know it was starting down here at -2. The period is pi. Let's see if I can kind of sketch it in here. Oh, no, it's got to come over more. Told you I'll need an artist in here who can draw these. This side doesn't really look right either. Okay, so it's looking something like this without the phase shift. Okay, are you with me there? It's looking something like that before I talk about pi forced to the right, because it has an amplitude of 2, it has a period of pi. I've got that showing right here. But now they tell me I've got to move it pi force units to the right. So I'm going to take this blue dashed curve and move it pi force units to the right. If I'm moving it pi force units, first off, let's note, where did that go through right there where I put the red mark? It went through at pi force, didn't it? Because halfway from 0 to pi halves is pi force. So I'm moving it pi force units to the right. So now that means that point that was at 0, -2 comes over to here. The one that was crossing through at pi force will be there. It's supposed to go up to 2. I don't think my first one did. Whoa, I didn't quite get that one. Here we go. Trying to clean it up here. Well, the more I draw, the worse it gets. That doesn't look right at all there. Let's stop it right there. How's that? We'll cut it off right there. But are you getting the idea of the sketch? That's what I want you to see. First, I had just the amplitude and period, and noted it was a cosine graph that was reflected over the x-axis. And then I put in that horizontal shift and tried to show you where it would move to. And definitely, it's a sketch. Okay, that's all that is a sketch, because it's a little bit off. Any questions there? Questions on my sketch, questions on amplitude, period, or phase shift on this one? So now we want to do number 11. Okay? After all that, now we can do number 11. Why did I wait till now? Because number 11, in addition to this stuff, it's going to have a vertical shift as well. So we're going to add one more thing to it. So now we're ready for 11 here, which says y equals 3 cosine pi x minus 2 plus 5. Okay. Amplitude? 3, right? 3. Period?
2.
Yeah, because it's 2 pi over pi, so that's 2. Phase shift? You got the phase shift wrong? Well, do you see it now, though, after we've talked about those others, that phi over omega? What do you think the phase shift's going to be here? Anybody can answer.
2 over pi.
2 over pi, right. Now remember, if you're not sure about how we're doing it that way, set that part equal to 0, pi x minus 2. That gives you pi x equals 2, gives you x equals 2 over pi. So it means we've got to move to the right 2 over pi units.
So you're just not really worried about the 5 yet?
I'm not worried about it yet, but I'm getting ready to. Okay? What am I going to worry about the 5 about? It's going to go up 5, right? So I'm going to put that up here. It just doesn't have a nice name like amplitude, period, or phase shift. You know, it's a vertical shift, but somewhere I want to note we're going to have to move it up 5. Now, When I'm graphing it, though, I'm going to go through this kind of step by step to try to help you see the graph for it, because I think it's hard to see all this at once for most people. Okay, maybe some of you can visualize it pretty well, but let's see. All right, I know the period, it has to go out 2 units. Then we're going to be shifting it some, so we got to have space for that, right? We see, again, it's a cosine graph. That's just coincidental. Every one I've picked so far has been a cosine. Don't forget about sines. They're out there, but this one's a cosine. Okay. First thing we're going to graph is this. First thing I'm going to put up here will be, in blue, I'll put up y equals 3 cosine pi x. I'm not doing the horizontal shift. I'm not doing the vertical shift, okay? 3 cosine pi x. That's about as basic as I can put this one up here first. So for that, the amplitude is 3. The period is 2. And it's a cosine graph. So the amplitude's 3, so I'm going to start up there. The period is 2. I've got this one really strung out here, so it's going to be kind of wide looking. It's got to go blue down to -3. Back up between those, like that, right? And hopefully look a little more like a cosine graph. Something like that. If I kind of started it there, it really continues on to the left. So we can note, it's doing this over here. It's going that way. So that is the basics there, right? The amplitude's 3. Does everybody agree? My amplitude's 3. The period's 2. It went out 2 units before I started repeating. So far, so good? Now we're going to put in the phase shift. 3 cosine pi x minus 2 in red. So now in red, what I'm going to do is I'm going to shift the graph right 2 over pi units. 2 over pi. That's a strange one. It's not one of our regular, it's not like the pi force that was kind of nice that we moved it a while ago. 2 over pi, though. You're trying to approximate that. About what would that be?
A little bit less than 2/3.
So yeah, so it's pretty close around 2/3 there, a little less than 2/3. It's pretty close in there. So because we know pi is about 3.14, so we can kind of guesstimate it with that. So around 2/3, we're going to move this thing to the right. So we're still, let's see, if we're moving it 2/3, then now it's going to cut through about over here from that point halfway over there. So I've got to move that 0.3 over 2/3. So I'm moving that over to there. It was to the right, wasn't it? Yeah. And kind of drawing through. This is where I really can't draw this. Okay, something like that. And let's see, that one moves 2/3 over, so something like that. And so on. See what's happening there? I shifted it 2/3 unit, approximately 2/3 to the right. It's a sketch. Not exactly a sketch. You see how I brought that over? My point up on the 3, I brought it over to the right, 2 over pi units. Where I crossed through down between 0 and 1, down there, at 1/2, I brought it over 2/3 units. Okay. Are you with me? It's a little sketchy, but I think we can get this here. Now I'm going to do 3 cosine pi x minus 2 plus 5. So now I'm going to, the one that was in red, I'm going to move it up 5 to further complicate matters. So where's this point? Where's that going to go to? Yeah, so up 5. Yeah, so it's going to be up here. And I take it up 5, isn't it? You see what I'm doing there? Taking it up 5. All right, so how far down, if I move that up 5, and my amplitude, well, my amplitude still has to be 3. So where's my graph going to?
So from positive 2 to positive 8.
Positive 2 to positive 8?
On the y-axis, yeah.
So this is the part, okay. Yeah, so this is what I'm moving right here. Essentially, if I move this, is everybody seeing what we're saying here? If we move that up 5, we're up there then, right? See what I just did? So it's like my axis is moving up there. So that's right. So we're going to take it down. The amplitude was 3, so it's going down to 2. Ooh, let's see if I can draw this one. Getting harder and harder to draw every time we do something different. It should look like the red one, but moved up. Okay? That's what it should look like. Does that make sense? It's getting a little tougher. My scale's off a little, I can tell. Something like that. Up there to where, all right, I'm putting this in here. This is not a horizontal asymptote. It's just showing you where that x-axis got moved to so that we're still measuring the amplitude the same. Period should still be the same. Okay? It had already been shifted over to the right, and all we did now was move it up. So this was the graph we were really looking for. The black graph. Is what we were looking for. We just used the others to get there. Anybody have a question on that part? Step by step by step. Yeah. Well, definitely be able to tell me the amplitude, period, phase shift, if it's moving, up or down, if it's reflected over the x or y axis, anything like that, and give me some sort of semblance of a sketch. Right? Go ahead.
Why did you move it 2 times over?
Okay, the phase shift was 2 over pi to the right, and pi is approximately 3.14, right? So that's like 2 over 3.14. So we're not using a calculator, though. But 2 over 3.14 is pretty close to 2 over 3. Okay, so that's why we went with 2/3. Just kind of in that general area, since we're being sketchy here. So we can kind of guesstimate where we're moving to or how far. Guesstimate somewhat scientific estimates, right? Somewhat scientific estimate is a guesstimate. So we'll try to make them be at least. All right, so this one moved right and up. We had both types of shifts. We still had the amplitude, period. We're going to have those anyway. It looks a little tricky maybe, but questions there? So I want to go back to another part in just a moment. Back in section 6.4, I want us to move back over to, I'm using something off page 405 for a minute. Is everybody finished with this screen? Are we okay to move that one for now? So back on page 405, I'm going backwards just for a second. We had problems like 61 there, where it told us the amplitude is 3, the period is 2. Okay, they use colons. I kind of like equals. But anyway, the amplitude is 3, the period is 2, and it said write the equation of a sine function with these characteristics. Do you remember those? That was back before we knew about phase shift. So at that point, we were just looking at the functions as y equals a sine omega x. That's what we were seeing there. So we know to write that sine function, we would have y equals 3 sine omega x. But we also know we don't just leave omega there in the equation. What did we do to get the omega value back here? We knew that period was equal to 2 pi over omega. So what did we do to get the omega value? No, he's shaking his head no. No. Anybody? If period's 2 pi over omega, then it has to be equal to 2, right? That allows me to solve for omega to get it for my equation over there. So I would multiply both sides by omega. Those cancel. So I get 2 pi equals 2 omega. Now I would divide both sides by 2. Those cancel, so I get pi equals omega. Okay, so that's what we take up to go there. We did these. It was 2 sections ago. We did them though, remember? Looking at these? Okay. Some of them, I think the one we did in class before, we had a graph, we had a sine or a cosine wave, and we had to decide if it was sine or cosine. Do you remember that? We looked at one and we had to figure out by looking at the graph what the period was and what the amplitude was on that graph. So we were finding those ourselves instead of them saying amplitude equals, period equals. We actually were doing a little more work when we did it that way. So my equation here will be y equals 3 sine pi x. Okay, y equals 3 sine pi x. Is the amplitude 3 in my equation? Yes, it is. Is the period 2? 2 pi over pi is 2. So it meets the conditions set forth. Is there a question there?
You have 2 pi over 2, how can we multiply it so we cancel it out?
This right here, are you on that step? Okay, the question is, y'all don't think you all heard this, but when we had 2 pi over 2, why didn't we multiply to cancel out? Actually, on this step right here, I think we're looking, I was dividing by 2. I was dividing by the blue 2 because, here's what it said before that. I'd canceled out the omega and I'd gotten 2 pi equals 2 omega. So I was trying to get omega by itself, so I was dividing both sides by that 2 that's over on the side with the omega. Okay. Does that answer clear that up? Okay. Anything else on this one? Go ahead.
Where are we getting the 2 on the omega side from?
Where are we getting the 2 on the omega side? This 2 right there?
Yes.
Okay, that 2 came from, let's see. They told us the period was equal to 2.
Okay.
We know the period is equal to 2 pi over omega, so
Got
we're
it.
setting those 2 things equal to each other.
All right.
If they're both equal to the period, then they must be equal to each other, right? Anything else on this one? It's a good thing we went back to this, I think. In fact, well, yeah, it's a good thing we went back. Let's go back over. We're going to write an equation now and put in a phase shift also. That's why I wanted us to go back there to see what we were doing. So now I'm back over on page 424 for another example here. We'll use number 16 off of this page, where the amplitude is 3. The period, this part's going to work exactly like we just saw. Period is pi halves. We're going to add one more thing, phase shift. I'll just put PS. You all know that's phase shift. That's my shorthand of the morning. Phase shift is 2. Okay. So we've got amplitude, period, phase shift. Now that we know, and they still want us to write a sine function, so that part didn't change. Y equals A sine omega x minus phi. We got all that stuff now. So first thing I know, this part's good. I can put y equals 3 sine omega x minus phi. Problem is I still have omega and I still have phi. And I don't want those in my final equation. So now is where the work comes in. The amplitude part's not really any work, but now the work. All right, so I know that the period is really equal to 2 pi over omega. They're telling me that the period is equal to pi halves. So I want to say 2 pi over omega must be equal to pi halves then. The period's 2 pi over omega, but they told me the period was pi halves, then 2 pi over omega has to equal pi halves. You agree there with what I'm putting down? So what's omega? Work out that omega for me. You can cross multiply on this one. You know, it's fraction equals fraction. Do the cross products equal to each other. Cross product equals cross product when you have fraction equals fraction. Y'all remember that? This equals this. And you've just got one fraction equal to one fraction. You can do that and make your life a lot easier. So what do you get for omega? I heard 2, I heard 4. I think it's 4, so if you got 2, look back. See why? I do think it's 4. Yeah, I'm going to show you how I got it. Is anybody else seeing 2 or 4 or what? Or something different? 3? I don't know. So I don't think you're going to see 3. Okay, here's what we get when we cross multiply. I got 4 pi, because 2 pi times 2, right, equals what? Omega pi, right? 4 pi equals omega pi. What would I need to do? What am I solving for? I'm looking for omega, so what do I need to do? Get rid of pi by dividing. When I divide, it causes them to cancel out on the right as well as on the left. So now I'm just left with omega equals 4. Okay. To put in that spot. Are we okay on getting 4? We see it now? All right, likewise, they're telling me the phase shift is 2, but I know phase shift is equal to what? E over omega. And in this case, then, I know what omega is now. It's going to be phi over what was omega? I just found it. 4. So, yeah, getting my phase shift correct is dependent upon having gotten the omega value correct. So, now I'll have phi over 4. That sounds like I can't say 3 or something. Phi over 4. Phi over 4 equals what? 2. Okay. I can still cross multiply if I want to. What would I get? Phi equals 8, right? Phi equals 8. Do you see that? Or you can just multiply both sides by 4. Either way. But I could have said, you know, that's 2 over 1. So phi equals 8. Right? Are you with me there? Some of you are looking a little bit like you might not be with me. Where's the question? So I said phi times 1, if I cross multiply, phi times 1 equals 4 times 2. Okay, that's what I'm doing when I cross multiply. To give me phi equals 8. Are we okay on that? Yes, go ahead.
Because we have to, the phase shift because it switches, and we have to think about it differently. Do you just take the 8 and plug it into phi and leave the problem the way it is, or do you have to think about, well...
Okay, this is a good question. You all aren't hearing it over there, but the question is, because we have to think about it differently when we do the phase shift, do we just put the 8 in for phi? What do we do? How are we going to write our equation? That was my next question for you. What's the equation going to be? Y equals what?
3.
3 sine
4x minus 8.
4x minus 8. So I just stuck it in place of phi. I left my form of my equation like it was, omega x minus phi, right? So I put in the omega in front of the x, and then minus the phi value that I got. Now, let's double check ourselves here. I always recommend for you to check if you can check yourself. And this is a good type of problem to be able to double check and see what's going on. On my final equation, do I have amplitude equal to 3? Like it was supposed to be. Remember, I was given all the parts I needed here. Is period pi over 2? I would be saying 2 pi over 4. That's pi over 2. Is phi over omega equal to the phase shift 2 that they gave me? So I would be taking 8 over 4, which is 2, right? It's a shift to the right, 2 units. We saw we're seeing inside those parentheses we've got minus. We think about it opposite, okay? So we do just stick it in there. What if it come out to be phi equals negative 8? Then what? In my parentheses, it would have said plus 8. Yeah, that's what happens. So, all right. I don't know which problems I'd ask you to look at on these, but I'm going to give you a few more here to look at. Go ahead. You've got a question here.
Yeah. Why would it use sign for x?
X is part of our equation. We're just getting an equation for a sine function that has those properties of the given amplitude, period, and phase shift. So X typically stays in our equation because that's where we plug in our values to see what we get out for Y. Okay, so it's like when we write an equation, a linear equation, y equals mx plus b. We fill in for the m and the b. We get like y equals 3x plus 4. Does that make sense? So we don't really replace that x itself. Another question over here. Would you let them hear it too, please? I'm sorry? Could I do a cotangent or tangent one? We're not writing equations for those. Is that what you're talking about?
No, just like
a graph? Okay, yes, we can do one of those. Okay. All right, some other practice problems from this part, page 424. And I don't know, I may have already told you these, but 3 through 17, odd. You could try 27. Okay. For some more from 6-6, okay? And odd ones, you have the answers in the back of your book. Okay, even if you're using the e-book, they should have the answers there on the e-book on My Math Lab. So a tangent or cotangent graph, that would be back in 6-5. And then I want to kind of run through the things you want to think about for the test, okay? So I want to take a little time to do that as well. Let's go over here on 6-5. This is on page 414. And I don't remember which ones we were doing, but I'll just pick one here. This is number 22. Y equals tangent 1/2 x. And maybe the best way for you to think about sketching this is to think of, plotting points. Sometimes people like to plot points. That makes it a little bit easier. Let's remind ourselves over here, y equals tangent x looks like this. Remember, tangent x was undefined for the cosine is equal to 0 because it is sine over cosine. We said cosine is equal to 0 at the integral multiple, not the integral multiples, the odd multiples of pi halves, right? Cosine is equal to 0 at the odd multiples of pi halves. So at pi halves, 3/2 pi, that's where it's going to be undefined at negative pi halves. This is our basic tangent graph. I'm just putting it back up here for demonstration, okay? To get our overall shape, what we're looking like here. So this one that we're actually graphing up here, tangents don't have amplitude. They go, to infinity and to negative infinity. This one here is still going to cross through the origin because still if I put in 0 for x, I'm going to be working with the tangent of 0. Does that make sense on that one? So it's still going to look like that. What is that 1/2 doing, though, to the other values?
It's doubling them.
Is it doubling them or halving them?
I should double your asymptotes, I believe.
Well, let's see what it's doing. Okay. Let's see what's happening. It's because I put these in like this, but maybe we shouldn't do that here, should we? Well, we shouldn't. You're right. It's not going to be like that. I've got a little haste makes waste here. Take those asymptotes out of there. Let's put a few more labels. Excuse me. So some values you might see. We are seeing that we still have the asymptote here, though, because the tangent at 0, right? Let me think. Oh, not asymptote there. Gosh. Nope. Nope, nope, nope. That doesn't work. It's still crossing through at 0. That's what I was meaning to tell you there. That's what I said first, and then I was like, somehow I went to cotangent. How did I go to cotangent? I don't know. So it's still crossing through there, but what's happening now, look at your values, okay? If x is pi halves, like before where we had that asymptote over there at pi halves, if x is pi halves, then we're doing the tangent, let me put it here, y equals tangent of 1/2 times pi halves, if x is pi halves. See what we're looking at there? So y equals tangent of pi fourths. And we know the tangent of pi fourths is 1. So we get 1 there. Now before, it was when we, had pi fourths down here on this first one. If I put in pi fourths, I got 1 out. Now if I put in pi halves, I get 1 out. So like here's 1, which means if I put in negative pi halves, what am I going to get out? Should get -1. What happens at pi fourths then? I've got the tangent of pi eighths. Well, that's something that exists. I don't know right off what it is. Where are my asymptotes going to be here? Where's my asymptotes going to be? Can you see where? Can you tell? Well, let's look and see. What happens, let's put in something else. I want you to see the points here and see what's happening. If I put in 2 pi, what happens? I probably went too far for that, but if I put in 2 pi, what's going on?
It's the tangent of 1/2 times 2 pi.
Okay, the tangent of 1/2 times 2 pi, it's halving what I'm taking the tangent of. So it's the tangent at pi. What's the tangent at pi? Think of your unit circle. What's your coordinates at pi?
To get 0.
You still get 0, right? So we've gone over a little bit too far there to get to that place. All right, pi over omega is going to be the period. Remember? Pi over omega. So what's pi over omega here? Pi over 1/2 is 2 pi. So the period for this one is 2 pi. It's going out 2 pi units. Maybe adjust it over on this side before it repeats. Whoa, we don't actually have that out there, do we? We got something like this going on. It's really widening it out is what it's doing. It's widening those tangent values out because it's half up. We're shrinking it up there. That's what we're doing, so it's widening the values. Okay? We said if we put in 2 pi, we've got the tangent at pi. The tangent at pi, the coordinates were -1, 0, so it's 0 over -1 for the tangent is 0. The tangent at 3 pi, well, if we put in 3 pi halves, we're looking at the tangent at 3 pi fourths. What's the tangent value at 3 pi fourths? That's where we've got negative square root of 2 over 2, positive square root of 2 over 2. So it'll be -1 down here. So it's looking like Wow, this one's looking really strange to me up here. It's looking like we've got something like this going on here. Is that what it's looking like to you? Pi over 1/2 is 2 pi. So it's almost like, let's look at this one over here a minute. I think I'm putting in stuff wrong on it. That would be tangent 0. Tangent 0 we agreed was 0, correct? Then we had pi 4ths. Tangent pi 8ths, we're not using a calculator, so we don't know what tangent pi 8ths is, but we're going to have a value there. We know that much. We've got a value, so we don't want to use that one, though, for graphing. Pi halves. Tangent pi 4ths is 1, right? That's what we end up getting, tangent pi 4ths. We looked at the period being pi over omega for the tangent, so pi over 1/2 is 2 pi. So for our sketch here, you remember on the basic pi graph, it went like this to get that pi, that period of pi. So how are we going to get in that period of 2 pi?
We're going to put the asymptote
Yeah, at pi, right. So mine's not drawn correctly over here. I've got the values incorrectly. I don't necessarily have it drawn correctly here because I went, here's the problem right here. That's the problem. Why didn't y'all see that for me? That should be where the asymptote is, not where this value is. That should be on over at 2 pi. How did I go from 3/2 pi to 2 pi? Now I'm seeing the problem. Because 2 pi will be, up here somewhere. Okay. So we're going from, that should be negative pi. I skipped values on my notches down here. It's going like that. That's where our 2 pi period is, from negative pi to pi. Like when we look at the other one, negative pi halves to pi halves, it's a period of pi. This one is a period of 2 pi, starting at negative pi, going up to pi, because it's got to go through that origin. That's what we want to see there, is it's going through the origin. It's widening it out, though, a whole lot more where it extends that period. It's stretching out that figure. All right, here's what I want you to think about, though, okay? Here's what I need you to know. You have review problems listed on the front page of D2L on the news page, okay? They're there for you. They're in the chapter review. I won't list those back again right here then. You need to know unit circle, up, down, left, right, every way you can know it. And I'm going to give those back to you here. You've got the key to that because you've got it on D2L. You've got the unit circle filled out, so I'll give those back to you here before we go. You need to know what else. What else have we done? Now this is a big label here, trig functions. That's all we've done, the whole chapter 6. But what did we do with them? We found out the sine of theta is y over r. The cosine of theta is x over r. The tangent of theta is y over x. The cotangent of theta is 1 over the tangent, reciprocal, right? The secant of theta is 1 over the cosine. I want you to know them that fast, okay? Cosecant of theta is 1 over sine. Seriously, I do want you to know those things, okay? These here are the reciprocal functions. When we talked about the identities, the reciprocal identities we put. We also had what we called the quotient identities. Remember those? We talked about them today. I just didn't call them that. That's where the tangent is the sine over the cosine. And the cotangent is the cosine over the sine. What about the Pythagorean identities? Who remembers those?
It's x squared plus y squared equals r squared.
Okay, and we used x squared plus y squared equals r squared up here where we were doing the sine equals y over r, the cosine is x over r and all that. So then when we put them into the trig function values, that is the same idea where we have the cosine squared theta plus sine squared theta equals 1. Where we have tangent squared theta plus 1 equals secant squared theta. You already have all this in your notes. They're there, right? Cotangent squared theta plus 1 equals cosecant squared theta. We might need to use those somewhere. What else? What else have we studied? Even in odd functions, what to do if you have the sign of a negative angle. Well, for one thing, you can know where the negative angle is. You want to know about those angles and how they wrap around. You know, like if we have an angle that's 390 degrees, what do we know about the trig function values for a 390 degree angle? They're going to be the same as what? A 30 degree angle, right? A 390 degree angle. The angle's not the same, but it's going to have the same trig function values, okay? All right. All the things we've looked at with the graphs, I'm not putting that back up here because we just did those. We've worked on the graphs, amplitude, period, phase shift. Think about your even functions and odd functions. Even was the cosine and the secant, and odd was the rest, okay? We'll say. And I think we're out of time here. Does anybody have a question? Any questions there? Yes? Can you let them hear too, please?
Are you going to be really strict about the graphs, or are you just
The graphs should be sketches. I should be able to see, you know, like maybe some real point it goes through and the overall real shape that it looks like. If it's a cosine, let it look more like a cosine than a sine, okay? I understand their sketches. Mine are horrible up here, okay? Anything else? If you have questions over the weekend, please send me an email. I will answer you. It might be late at night, but I will answer you, okay? So feel free to send me questions. Go to the CFAA, get some help. Come show me what you know on Tuesday, okay? All right, thank you all. I'm going to give these back to you guys over here. Oh, wrong ones. Before you leave, let me hand this to you, okay? Let's see, Jamie Kinsler, Kyle Seaton, Larry Morse.
Right here.
Okay. Amy Spencer. Where's Amy? Okay. Grady Peters.
Here.
Juan Gisbert. Tom Zaleski. If you have a question, let me know. Thomas Elphick. Here. Veronica Morlock. Veronica, Chance Pritchett, Evan Riley, Stephen Scheidler, Brandon Delgado, Jacob Porter, Rachel McCauley, Clay, okay, Gerald Rivers, Aaron Mayer, Amelia Kuchulowska, Jonathan Beck. Oh. Sydney Lawson. Brett Rathbone. Sorry. All right, y'all have questions, let me know. Okay? Just leave that door open, somebody. As you go out, will somebody fix that door open for the next group, please? Thank you.
See you in 2 hours.
Yes.
Question. I'm sure somebody else teaches y'all, but those review quizzes on that, are they due the day of the test? Or
They're due at the end of the semester, but they might help in studying for the test, okay? Yeah. You're welcome. Yes. Yeah.
Writing an equation, and you're given the answer. When you write the equation, you plus or minus because the absolute value.
It could be either one, and either way would be okay. And we didn't mention that today. I started to say something, and I forgot to do that part, but it's most of the time we put the positive when we're writing the equation just because it's easier to think about. But it's true if you'd put -3, whatever, it would still be correct. Okay. Okay, you're welcome. Let me know if you have other questions.
Well, a bit like 9 this morning. Oh, God.
I probably should have woke up at 9. I was afraid if I went back to sleep, I would not wake up.
See, I actually woke up like 8:30, and I was like, I'm gonna go back to sleep.
I woke up at 8.
Looking, went to sleep at like 3. I was just like, I was supposed to show up in just like the shorts and t-shirt. Also, force myself to